This is FE Peer Review. The date is January the 20th, 2022. A look at atmospheric or marine inversions with Pablosdog.
This video is a brief look at atmospheric inversion layers and refraction. I've covered videos by Pablosdog in the past. He regularly produces videos of long-distance observations he does off the coast of Santa Barbara, looking towards the coastal mountain range or out to the islands or to the oil rigs out along the seafront there. Well, Pablosdog recently put up a post in his community section with a photograph of his and the peak finder. Too Many Hits left a comment. So the difference in elevation between Boney Mountain, this one up here, and Mugu Peak, this one over here, is 1,572 feet. Draw parallel lines on your screen or print this image. What is the distance between these lines? Measure down from each peak to the water line. What are the two measures? In other words, he's getting at where does this water line appear relative to those peaks in order to determine whether or not a portion of the mountains is being hidden from view. Pablosdog doesn't answer the question. He sidesteps it, avoids doing the real work. But he says, and when you can see buildings along the distant shore, then what? So what he's suggesting with that is that he can see buildings along that distant shoreline. So the implication is he's seeing the shoreline. Nothing is hidden. Well, that may be at times the case. It is most definitely not at other times, and we'll take a brief look through some of Pablosdog's images, and I'll show you examples where sometimes we do and sometimes we don't when looking at the same location. That in itself should be enough to emphasize that these kinds of images are not useful in making quantifiable measurements of the curvature of the Earth or the shape of the Earth. I mean, if from one image to the next there's a large variation in what is seen, then the image can't be relied on to provide a stable, measurable resource. So this is an argument for flat earthers to stop trying to use extreme refraction conditions that only occur occasionally as proof that the Earth is flat because I see too far, when the very next day or a week later you go back and you don't see too far. So then what? Obviously, the atmosphere is playing tricks. So if the atmosphere is playing tricks, then this is not a reliable way to come to a conclusion. There are other ways. However, I also thought it would be an interesting opportunity to look at why this happens. So let's take a look around the Southern California coast a little bit. This here is the coast off Santa Barbara looking south towards Los Angeles, and the peaks that are mentioned in that post by Pablosdog, I've put pins. One here, Mount Boney, and the other one here, Mugu. And then our distance, our location, our observation location is out here, UC Santa Barbara parking lot. So that's where he hangs out with his camera. There's the mountains in the distance. Gives you an idea of the lay of the land. But now I'm going to go and reset tilt and compass and just take you on a quick tour of the coast here. So we were looking east-southeast from our observation point. Los Angeles is down this way. What you see all along here is called the coastal range, the California coastal range. And the San Andreas Fault, which is responsible for that coastal range, runs right where I'm moving the mouse. You see it coming as a straight line right down through and right out through to Baja California. So the cities along the California coast are hemmed in between the coastal range and the shoreline. There's Los Angeles. Now, it's a notoriously difficult problem for air pollution because we get a phenomenon called a marine inversion or an atmospheric inversion where cooler air over the water is moving towards the land and hot air from the inland desert is moving towards the west. The hot air of the desert reaches these mountains and is lifted up. The cool air from the ocean is trapped in these valleys with the hot air going over it. So you have hot air over cool air. And this creates what's called an inversion layer. This is something that we've talked about since I was a kid, and we'd hear stories about how the smog was so terrible in Los Angeles because of the inversion layer, and they would have smog days where they'd have to wear masks and stuff. This is a little article about air pollution, and it shows a diagram here that describes exactly what I just showed you. It doesn't call this Los Angeles, but I have a feeling that whoever drew this diagram probably had Los Angeles in mind when they put it together. You've got the inland on the right and the sea on the left, the mountain range separating the town from the inland range. The hot air from the right comes across and traps the cool air coming in from the left. So this is a very long understood phenomenon of an atmospheric inversion, and this has extreme refraction effects. Here's a page describing Superior Mirage. A layer of warm air sits above your line of sight with a cool layer beneath it. This is also known as a temperature inversion. Light bends down towards the denser air, but because your eyes assume the light we see travels straight, the object we are seeing appears higher than it actually is. So this is a form of extreme looming. The term is looming when the mirage makes the mountaintop appear higher than it is. And they show you in this little diagram here how the light from the mountain, although the straight line is actually at a lower angle, by the time it reaches our eyes, it's reaching our eyes at a steeper angle, and so we consequently think it's up here. This is the consequence of an inversion layer. So you see in the diagram it says warm air, cool air, and cold air. This is what happens along that part of the California coast a lot. And this is precisely why Pablosdog can sometimes get some great variation in his imagery. So we're going to go look at a few examples. Let's start by looking at one of his observations from the UC Santa Barbara parking lot across and down the coast a little ways. I looked at this in the past, so I'm not going to go into a lot of detail about it. I'll put a link in the description to my earlier video. Basically, we're looking, I'll show you on Google Earth here. UC Barbara parking lot is over here, and we're looking past this piece of land towards the coast over here, Muscle Shoals and La Conchita. And there are these distinctive, very easily recognizable canyons that come down towards the water. In the earlier video, I determined that we were not seeing roughly the bottom 80 to 100 feet of that land between the hills and the water. Basically everything from about here over was missing, including Highway 101. And in his video, we'll go to his video here. This is it here. I'll play a bit of it. This is right here. Between these hills and the water is the Highway 101 and the town of La Conchita and Muscle Shoals. And we don't see any of that. We don't see the highway. We don't see La Conchita. We don't see Muscle Shoals. And then a month earlier, he did a video of the same stretch of coast. Extreme atmospheric conditions. You can see lots of movement in the atmosphere. And we can indeed see, it is taken from exactly the same spot, looking at exactly the same stretch of coast, and we can see the traffic moving along Highway 101, but you've also got a lot of miraging happening along the water. So we see the cars moving along. They're actually up here, and then we're getting a mirage of them. Here we see them better. See the traffic moving along there. So if I pause it, we can see that there's this whole mirage band, and it's like doing two mirrors with the cars up here, and then it's mirroring twice. So extreme, crazy mirage effects going on there. So that's one day, and then another day it's like this, pretty clear and clean and easy to see. Not a lot of distortion. A little bit right at the bottom. At one point, I think he zooms in and you can see the buoy out here, and it's a little bit fuzzy and a little bit weird, but that's just a good example of how extremely different the conditions can be from one day to the next. Here's one more example. We have on the left Hill House, the oil rig Hill House, and then the rigs A, B, and C. And we have something really weird going on with the atmosphere that day that's causing a line to appear all across the tops of them, and it's stretching them all vertically. You can compare that to this image taken a month or two before, maybe a month or two after, but exactly the same line of sight, same observer height and everything, but that's under one kind of atmospheric condition, and that's the other. Take a look at Hill House over here. The height of Hill House from the water line to the top, ignoring this bit of crane that comes off the top, and then compare that to the top of the mountain behind. It's about two times that. If we look at this image, it's about 4 times. 1, 2, 3, 4. So we're getting something happening between the mountains and the observer that's only affecting the middle zone of the image, causing all of this stuff to get stretched upward. So these are some examples of some of the crazy kinds of conditions you can get when you have the setting like the coastal range in California, those small valleys trapped between the mountains and the sea there, catching the colder air from the sea and having it contained with hot air up above. It's certainly not conducive to getting nice, clear imagery from which you could actually maybe do some kind of measurement. I mean, when you start to get clear pictures like this, and these zoomed in, you can see that they're pretty clear. It's conceivable you might be able to start making some geometric determinations from all of this, but when you've got that to deal with as well, it's really not helpful at all. So, lots of nice images that show all kinds of interesting atmospheric effects, but really not much to give us insights about the shape of the Earth here. Roohif has pointed out in a number of videos that it's more important to look at the mountains in the distance. You can look at these mountain profiles, and he's done this in a number of videos, and you can determine that large sections of land ought to be visible if this was a flat plain, which are not visible because they're being obscured by the curvature of the Earth. Check out Roohif's channels. I'll go find 1 or 2 of his videos and post a link. Anyway, that's enough. I think got the idea here. I don't think there's a whole lot more to do with Pablosdog's videos. They're all pretty much the same thing, and I've pretty much been through it all. I did get some nice images and a suggestion from one of our regular viewers. I'm not sure if he wants me to identify him by name yet, so I'm not going to say his name today. But he sent me some pictures and some thoughts about doing one more on Pablosdog. After that, I'll probably move on to other things. Anyway, that's it for now. Remember to click that like button and subscribe, and I hope you all enjoyed this. Have a great day. Bye-bye.